Here we go again. IPSec site to multi-site. So in this video, what I'm going to be doing is I'm going to be creating a crypto map and applying IPSec to two different networks. So here we have the super secret squirrel network and then the not as super secret squirrel network on this side, and we have the headquarters squirrel nest on this side right here. And I'm going to be configuring R1, and I'm going to create one crypto map but apply two different ITK policies, and it's one each is going to go to R3 and one's going to go to R4. But you can only apply one crypto map to an interface, so I'm going to show you how to do IPSec site to multi-site. Here are the steps that I'm going to go over, and as I'm doing it, I'm going to be talking you guys through it, and that should be it. So let's get to it. Here in R1, let's go into config T. And the first thing we're going to do is define an ITK policy. So this is used for phase 1 negotiations, and this will create the ITK tunnel. So we're going to do crypto ITK policy and then the priority of the policy. Now when you create this ITK tunnel, what policy is going to be applied is it's going to look for the first priority policy. So if I put policy 1, everything I'm going to put in this policy, everything I put in this policy, it's going to try to match to the distant end. And if it doesn't match, then it'll go to the next highest priority, which would be priority 2. And if there's a match, then the ITK tunnel will form. If not, there will be no tunnel formed. So, policy 1. And what are our options here? We have authentication, we have encryption, there's a group for a Diffie-Hellman group. You could apply a hash, and you could specify the lifetime of how long this ITK tunnel will be up. So let's start off with encryption, and we are going to do AES, and we could actually define what how many bit keys we can apply here. So I'm going to apply 256, and we're going to do a hash, and there's two options, MD5 and SHA. SHA is a little bit more secure, but MD5 has a smaller digest, but it authenticates quicker. So we're going to do MD5. In the authentication, we're going to use a pre-share key. We could use RSA encryption and an RSA signature, but that will require a certificate authority. And right now, I don't have anything hooked up like that, so we're just going to use a pre-shared key. And then we could define a group, a Diffie-Hellman group on this router. It only supports 1, 2, and 5. 1 being the less secure. I think it holds like a 768-bit. And 5, I think it used 2048. Not sure, but 5 is the most secure, so we can just use that. And that should be it for the first policy. Now I'm going to create two policies. Router 3 is going to use policy 1, and router 4 is going to use policy 2. So let's go ahead and create another policy. So crypto ITK policy 2. And this one we're going to use different encryptions. So we're going to do 3DES. Authentication, we're going to use a pre-shared key. And for the Diffie-Hellman group, we are going to use 2. Good, that should be it. So now we're on step 2. Define an ITK key for peers. So we're going to do crypto ITK key. What are our options? 0 to specify a unencrypted password following it. So it'll be CCMP Seth. And then the address of where we're going to send this key. And this first key is going to go to the public IP address of R3. So that's going to be 23.23.1. And then we're going to do another key for router 4 right here. And it is going to be CCNA Seth address 24.24.1. All right, so that's it for step 2. Step 3, define a transform set. So crypto ITK transform set, and then we have to name it. So we'll just say trans_IPSec. And then this is where we actually specify what type of encryption we're going to be using and what type of authentication we're going to be using for the phase 2 tunnel or the IPSec tunnel. So here, the first one, we are going to use AES, and we can actually use a 256-bit key. And then what kind of authentication? We'll use SHA HMAC. All right. Now I'm going to create another transform set, and that's going to be used for our 4. So again, just hit the up arrow and change what's different. I got to name it something different, so we'll just say transipsec2. And the encryption we're going to use is, whoops, let me exit out so I could do the up arrow. Clear that out. 2 ESP, and we will use DES this time, a 56-bit key. And then the authentication, we'll do MD5 HMAC. All right, that's it. Now let's create the crypto map. We're gonna create one crypto map, but it's gonna have different sequences, and that's going to be for different peers. So we're gonna do crypto map, and then we have to name it. So we'll just say R1 crypto underscore map, sequence of 1, and then IPSec ITK-KMP, saying that we are going to use ITK-KMP. All right. Now, what's it say here? This new crypto map will remain disabled until a peer and a valid access list have been configured. All right. So we got to set that up. So we're going to do set peer, and then who we're trying to peer with. Well, this one's going to be for R3. So we'll set peer, set the transform set, and the first one I did is trans underscore IPSec, and then match, and this is the interesting traffic. This is this valid access list that needs to be configured. What traffic, what interesting traffic are we going to monitor and send down the IPSec tunnel? So this is going to have to be an access list word or number. So we're just going to do access list 100. All right, that should be it. Now let's create the second sequence for this crypto map. So crypto map R1 underscore, what is it? Crypto underscore map, sequence 2, IPSec ITK-KMP. All right. Now let's set the peer. This is R4.1. Set the transform set. We set to trans underscore IPSec 2. That's what that one was. Set the transform. Yep. And then match address. And we got to create another access list, and I'll do that afterwards. 101. All right. That looks good. So let's create our access list so we can capture the interesting traffic. So we'll do access list 100, permit IP traffic from the source 15150 with a wildcard mask of a 2024 or a 255, and it's destined to 36.0 with a 255 at the end. Enter. Good. Now we need to capture interesting traffic for R4. 47. And the access list is going to be 101. Alright, so now we created it. Now let's apply the crypto map. So we go in the interface that we're going to apply it to. We're going to do crypto map, and then whatever we named it, which was crypto underscore map. ITK-KMP should be turned on. And let's do a quick ping to, nope, that's show. Ping 36.1. Alright, now let's see if we could bring up the tunnel. We'll do a source of F1/0, which is this interface right here. And the tunnel needs to be built. We lost one packet. Alright. I'm going to go over some show commands, but I only have a 10-minute window in my videos. So this is going to be part 1, and there will be a continuation video, and I'm going to explain more of what's happening. Alright.